Do it?
Yeah.
Oh, I think you could just leave it.
Or just talk really loud.
Talk loud.
Point it towards
Where are you going to be?
Okay, we're live.
We're live. Okay.
Hi, viewers from home. I hope you can hear okay. We'll find out afterwards when we watch the recording. If you are watching, you can play around with our Q&A app, which is just a Q&A bubble on the side, or you can send in questions. And we'll probably wait till Joe's done talking to field those questions, so don't be discouraged. Okay. I'm hoping she did screen share.
She did mention trying to do that.
Just in case, I will just. Okay. Should be good.
Okay.
Is this one? PowerPoint screen share, right? You should go through this one. Okay.
Good.
We'll see what happens.
Okay, we'll get started then. Okay, welcome everyone. Thank you for coming. Welcome to Classroom A. My name is Joe Svoboda. I'm an instructor here at the Bronx Zoo, and I'm here today to talk to you about the Hudson Canyon system. A very interesting place, about 100 miles offshore New York Harbor. A site of great biodiversity. Very important for our local fisheries, and just an all-around interesting place. So I'm going to start just by taking a look at this beautiful watercolor that we have here. And this was designed by one of our artists here at WCS. And it shows just part of the diversity that's found in this area. And we'll take a look at a map in just a moment. So yeah, many different species of fish and large mammals and invertebrates call the Hudson Canyon their home. So we're gonna talk about them, and one thing that just from looking at this picture initially is one of the reasons I wanted to talk about Hudson Canyon. It is, like I said, a biodiversity hotspot, and I just want to kind of think about and talk about today why that's the case. Why are so many organisms found there, and also a little bit of what can we do to protect this area as a conservation organization. So we're going to do that. By following this general outline. Once again, my name is Joe Svoboda, and there's my contact if you're watching this online and you have any questions. We're going to also archive this, I believe. So if you're watching this at a later date, and it's not February 10th, you can feel free to email any questions you might have. So we're going to talk about the geological history, research in the canyon. I'm going to mention a WCS project that's taking place in the area. And I'm going to close out with some human impacts to the area before we get into a discussion, a Q&A. So just a quick disclaimer is I am not really an expert on the Hudson Canyon. I've never been out there. Actually, I was out that far at sea once, and I got really sick. Didn't go that well. I've never been out there on a research vessel, never been in a submersible diving down there. The reason I'm talking about this is so we can together kind of just discuss the basics of the canyon, and hopefully you guys will have some good ideas during the discussion portion. I'm definitely looking forward to hearing your thoughts on the matter. So here we go. We're starting here with a Google map. And the latest rendering of Google Maps actually shows you seafloor terrain. So this is kind of cool. We have a view of the Hudson Canyon, and I'm going to point it out right here, about miles from New York Harbor. And for those of you at home who can't see where I'm pointing, that yellow box hopefully helps you out. So that's the region I'm going to talk about. You can sort of actually see on this map the Hudson Shelf Valley is a depression that connects the Hudson Canyon with New York Harbor. So you'll see a slight indentation connecting these two areas. I'm going to talk about the Hudson Shelf Valley a little bit as well today. Okay. So yeah, just a little oceanography 101. Hudson Canyon, not an oceanic trench. It's a deep chasm in the ocean, but it's not that deep. So we're not at 10,000 meters below the surface of the ocean. What we are talking about is an incision into the continental shelf, slope, and rise that bottoms out at the abyssal plain. So it kind of cuts down into these areas like so. And again, those of you at home probably can't see where I just pointed. So here we go. Toggle back and forth there. So that's kind of what we're talking about on this image, is kind of a deep cut into those parts of the ocean floor. See that? Everybody see that? And here's another angle. So say if we were standing on that volcanic island in this diagram, we would kind of be looking at this cut, this scar that cuts right into the shelf and slope. And so just to talk a little bit about the origin, when did this scar form in the slope and shelf? Well, origins are a little unclear, but we know that there was major violent erosion during the last ice age. As the glaciers were kind of retreating north, the Hudson River actually ran across the continental shelf. Sea levels were much lower during this time period. So all of this orange area or brown or whatever color that is, that was all land about 10,000 years ago, and it was the ancient Hudson River. So this scar here really started opening up and forming during that time period, and we can see it goes from about a depth of about 200 meters all the way down to about 4 kilometers down to the abyssal plain, and that's very deep. So to give you a little perspective, our tallest mountain here on the East Coast is part of the Appalachians. It's Mount Mitchell, and that's only 2 kilometers high. So this is about twice as deep as our highest mountain here on the East Coast. And so it's been kind of compared to the Grand Canyon a little bit. It's almost as deep at some points. It's about 3/4 of a mile looking down in some areas. So it's a massive canyon, and has an ancient history that goes back at least to our last ice age. Okay. So this is the New York Bight, which does contain the head of the canyon, and it's an area I'm going to talk about quite a bit today. So we have the head of the canyon over here, and then the Hudson Shelf Valley connecting it, and you can see the impression that erosion and sediment transport has left on the continental shelf here. So the New York Bight does contain the Hudson Shelf Valley as well as the Hudson Canyon head. Okay. So this is an interesting area that's really just starting to be looked at. We're kind of at the preliminary phases of exploring the Hudson Canyon. And I should mention, I'm going to go back a bunch of slides. You will notice not only is the Hudson Canyon here, but along the continental rise, you see a whole system of canyons with a lot of similar features. And so scientists are just beginning to study those areas. And this is the Oceanus Explorer. It's a very fine ship. It's a U.S. government exploration vessel, and it's focusing on the seabed and ocean crust. That white sphere, pretty cool feature. It's a satellite dome. And so what we're going to do now is take a look at some footage collected by this ship. What this ship does have on board at all times is a remotely operated vehicle that can go down to depths of 6,000 meters. And so we're going to take a look at a video, and Erin's going to help us out. Minimize.
Or you're going to do it just a little bit differently.
We want the lights dimmed at all?
Yeah, I think we should.
Okay.
Pilot is ready.
Going down. 50 meters and hold, please.
My name is Amanda Demopoulos. I'm from the USGS. I'm here with Martha Nazinski on the Oceanus Explorer.
We launched the ROV this morning about 8:45, and we have been surveying the east wall of Black Canyon. We're currently about 100 miles off the coast of Rhode Island, pretty much due south.
We are working up our first wall transect. Large number of corals, including huge numbers of deep sea corals, probably some of the more densely populated wall face that we've seen on this cruise. It looks like it's transitioning to a lightly sedimented covered top.
Among the corals that we've seen today are several species that we haven't seen in other canyons. Yeah, that's our first true lepidisis.
Do you see the one in the back?
Yeah,
it's different.
Whip bamboo, it's called curling.
And really, for those of you who are just joining us maybe for the first time, you have tuned in at just the right time, because we've just been seeing just fantastic colonies of corals here. Let's call it the coral forest.
Coral forest. My record showed that this is the first official target of the dive.
Yes, I believe that's true.
You got it. Coral forest.
Thank you. It's only through exploration like this that we can get these views to really understand how these corals are distributed and how they're using this habitat.
I count 3 egg cases. You see one on each branch, kind of on the tip. They're sort of this brown color. You see the ophiuroid arms kind of coiled around the egg case. You can see the polyps close up as the shrimp is walking across the coral.
And more deep sea predation. That's really interesting to be able to see these mating pairs eating.
Oh, it was a swordfish.
Swordfish, wow.
Oh, awesome. Oh my goodness. That coral has the fish. Those are scale worms crawling along the branch of the black coral. Wow.
My goodness.
That's awesome.
What is it, Scott, do you think?
I've never seen anything like that before. You know, I think this is really interesting. If I'm not mistaken, this is the first metallogorgia that we've seen this far north, not on a seamount.
That coral represents a new family that we haven't been observing on this leg.
That may be a species in a new family. We've had a few other specimens look similar to that were collected in the Gulf of Mexico. So again, with all the exploration that we're doing, we continue to find new species for science.
Quite a deep cut. It appears to be cut into the wall, but doesn't extend deeply into it, which again makes me think it's anthropogenic fishing line being dragged up.
Every dive so far we have seen trash. We have seen discarded fishing gear.
This is a huge debris field of cup corals, all dead, all littering the bottom, which suggests that we probably have a good wall face in front of us. We've seen a lot of bamboo corals, yet we haven't seen any really even medium-sized ones, or certainly not any large ones. We've seen maybe a couple of old, toppled over holds of bamboo corals, but nothing that suggests that they have been allowed to grow or growing for an extended period of time, i.e. that 80 to 100 years kinds of things.
Wow.
Wow.
Like some battle scars on that thing.
There's speculation that it might be a Greenland shark.
Greenland shark.
Yes.
Your purple blob is Tritonia, probably a new species, a nudibranch.
Wow. A new species.
Appears to be an egg mass. Andrea Quattrini is saying perhaps these are fish eggs.
We're seeing clear, dark rock colonized and crusted with all of these different animals.
Colony coming up here. Let's see what that's all about.
Corals aged there several hundred years old is a conservative estimate at best.
And that is quite an impressive base now that we're even closer.
We need to finish this shot.
It's amazing that we always seem to end our dives with just a fabulous image, one of these spectacular corals or other organisms that we are viewing. Thank you, ROV team and video, for all your help today in making this another successful dive.
Okay, we're back. All right, so what did you guys think of that video? Cool. Okay. One reaction is cool. I agree. It's very deep. So the areas we were looking at were about 450 meters to about 600 meters. That was the max of the vehicle. And it's entirely in the aphotic zone. There's no light reaching down to those depths. So most corals, yeah, they do interact. They do have symbiotic algae, and they're usually in shallower environments. But not all coral needs light. In fact, all the coral in this region survives entirely without light. And there's no photosynthesis going down in the canyon. All of the energy, all the primary production is happening elsewhere and then traveling into the canyon due to currents and sinking and those types of actions. So it's really fascinating that there's so much diversity down there with really no life. It's pretty cold. I have a paper that talks entirely about water. The thing about the area, though, is it's very dynamic. So sometimes there's very cold water there, and then other times very warm water from the shelf drains into the canyon. And over several years, there doesn't seem to be a reliable pattern to the water temperature down there. So it's an area that's very much in flux at all times, and we're still learning. We're still learning exactly all the interactions that are happening. But generally, it is colder down there. It's cold, and there's a lack of light. So it doesn't seem like an environment that would support a lot of life, but it does. It does, and we're going to hopefully explore some of those reasons why. Yeah, go ahead. So yeah, the ocean currents do deliver a lot of nutrients and a lot of inputs into the system. Yes, it's quite complicated when you kind of look at all the different forces at play. But definitely, yeah, the energy entering that system comes from elsewhere. So yeah. Okay. Any other thoughts on the video? Cool. All right. Well, I just enjoyed it. I was surprised the first time I saw it. Really didn't think there would be coral and that much life down in the canyon. But the Oceanus Explorer was able to capture some really good footage and has really made some advancements regarding our understanding of Hudson Canyon and the entire U.S. Canyon system. So what we saw was not just Hudson Canyon. What we saw was footage from it's kind of like the best of the summer of 2013 throughout all of the Northeast. So I'm praising this boat here. There was obviously a team of scientists working as well, and I'm going to get into some of them now. Actually, I'm going to talk about a different boat and a different group of scientists next. So yeah, here we go. Look at this crew. This is a team that specifically focused on the Hudson Canyon. And like I said, different boat, different crew. And one person I want to give a shout out to is, here we go, on the left column, second one down. That is my college advisor, undergrad advisor at Stony Brook University. Go Seawolves. So that's Dr. Mary Scranton. And if you're listening, Dr. Scranton, you could be listening. She could be on here, right? It's possible. Thanks for everything. You're an excellent advisor. Doesn't she? She looks like a really good advisor, doesn't she? She does. Yeah. She was. And she was. Her interest in looking at the canyon was looking at methane in the water column. And there is methane. There's methane in Hudson Canyon, which is interesting for a number of reasons. It has to come from somewhere. So part of what this team was doing, and just a small portion of what they're doing, is finding the source of methane in the canyon. And 4 reasons why methane is significant. Number one, it's a source of energy for biological communities. So you guys have heard of hydrothermal vents and the communities, the chemosynthetic communities that surround them. Methane seeps are thought to be down in the canyon, and it's a very similar kind of community. So there could be animals existing off of this methane. Number 2, methane contributes to climate change, and so we want to keep track of all possible sources of methane. Methane could cause earthquakes down in the canyon, so we want to be aware of that. Okay, it causes the seafloor to be a little volatile and could lead to potentially small earthquakes, tsunamis hitting the East Coast. That's not good, so we want to keep an idea. We want to keep that monitored. And so those are the major reasons. The fourth reason is escaping me right now. We'll get to that, I think, a little later. Okay, I'll talk about this team a little bit more, not just Dr. Scranton. Their idea for researching the canyon was to look use a number of different methods. So number one, they're looking at the seafloor, bouncing sonar off of the seafloor to figure out depth, to figure out particle size. That's the yellow area. Number two, they're taking photographs. So I think I have some slides that get into this. Yeah, so using this torpedo-looking device, this is going to be used to map the seafloor. So again, it gives you information on depth. It gives you information on particle size. Okay. Oh yes, and using that that data, you can create maps like this. So this is the head of the canyon, and it's broken down into 5 different particle classes. Really interesting what they can do just from using sonar. They also took photographs of the seafloor using the CBOS, and you can see it's video attached to a frame that's carried by a ship, and also has the ability to scoop up sediment, take sediment samples. You put this together with the sonar, and you can generate a map like this, which breaks down the area they covered into 8 different habitat types. And this diversity of habitat is one of the main reasons there's biodiversity in the area, is because different organisms prefer different areas of the canyon. And this is an excellent map showing just the different habitat types found there. And this is habitat G. These are where the methane seeps were found during this study. So Dr. Scranton was right on track and was able to locate them. All right. Well, here it is again. The last thing they did were a series of trawls, and the trawls are represented by the green lines here, and here's what turned up in the trawls. So a trawl is a big net that's dragged along the surface of the seafloor. And these were, let's see, there were about 60 different fish species that turned up here, and these were the most abundant ones. Each one of these fish is significant to our fisheries off the coast here. So all of these fish we either eat or someone else in the world eats. We ship them off all over the world. So we also found a lot of invertebrates. I have the number right here. 1 second. So just to give you an idea of the diversity found in the canyon, let's see. There was a otter trawl that turned up 43 invert taxa, and then a 2-beam trawl turned up 30. So 73 different invertebrate species, including coral. The Hudson Canyon does not, as far as we can see so far, support the huge coral diversity we saw in the video. Those are mostly from neighboring canyons, but we do have some stony coral and a number of invertebrate species that turned up in the trawls. Okay, and so this study was significant, and the video we saw was also significant because it's led to a movement to protect these areas that's currently underway. This is a proposal by the Mid-Atlantic Fishery Management Council, and they sent this to the Department of Commerce for approval. The plan here is to protect all areas here in yellow. That's the broad coral zone. Based on studies, that's where coral is found. That's the area they're looking to protect. The green line there, that's international waters. so we can't really protect that area. On the left, you'll see smaller kind of areas. Those are also slated for protection. Those are the canyon systems of the region. So those areas would be entirely exempt from fishing. The broader area here, you can still fish red crabs in this area because it's the method for catching crabs. It doesn't tear up the surface, and we saw a little bit of that in that video we watched. Okay, so this is happening right now. In fact, tomorrow in New Bern, North Carolina. Road trip, anyone? Let's go. Let's do it. So there is a council meeting tomorrow. Here's the agenda. I personally won't be able to attend. I'm teaching a rainforest class tomorrow. But yeah, it's happening. From 9:30 to 10, they will be naming the deep sea coral protection areas that I mentioned, these areas in the last slide. So yeah, if anyone wants to set up a carpool, we can talk afterwards. Okay, so I'm going to transition a bit and just try to plug some WCS work that's being done in the region. And there's actually a Google Hangout that's archived. Is that right, Aaron? That from Professor or Dr. Rosenbaum studying whales. Is that somewhat accurate?
It is it's an archive of a teacher webinar. It's not a Google Hangout. It's done through our webinar platform, Blackboard Collaborate, but it's very easy to access, and we can share the link. You would just click on the link, and it would go right to it. Your computer would quickly download a driver, and you just press play. So it's and it actually is a great presentation. Howard had solid, really engaging data and information, gorgeous pictures. So it would be worth reviewing.
Thank you. Yeah, that's great. And so I'm just gonna kind of touch on his work. And if you're interested in that, you can click that link as Aaron, as we provide it to you. So what we're looking at in the New York Bight when it comes to whales is we're going to be partnering with Woods Hole Institute, Ocean Institute, and we're looking at a number of different questions. How are whales utilizing this area? How long are whales present in this region? How many whales are out there? And how important the waters are to migration and feeding of the many different whale species that visit our region. And ultimately, I think WCS plans to make real-time whale tracking information available eventually, I think, at the New York Aquarium and via the internet. So this is kind of a cool project. You'll be able to actually see whales in near real time as they visit our waters. They're using some acoustic tracking methods. So yeah, if you are interested in that, we can provide those links to you and you can learn a little bit more about that project. Okay. All right. So I'm going to shift gears slightly again. I want to talk a little bit about human impacts in this region. So I gave you some science, I gave you some of the latest research, and it's very exciting. It's very cool to see all the different organisms that are found in our area, despite the history of the New York Harbor area, the New York Bight, and all we've done to this area. I know the text is a little small here, so I'll read it off for you guys. So from this point on, I'm going to be talking about human impacts, mostly ocean dumping that's been happening in these regions. So the Office of Supervisor of New York Harbor was established by an act of Congress in 1888. The harbor supervisor is responsible for the designation of specific disposal sites and for ensuring that ocean disposal would not be detrimental to navigation or pollute adjacent beaches. Materials include garbage, city refuse, cellar dirt, floatable materials, and sediments derived from dredging during the maintenance, deepening, and construction of new channels in New York Harbor are to be dumped at specific locations in the New York Bight apex. So there's a long history of us using this area as a garbage dump. I'm going to get into that a little bit here. So in 1888, we started dumping. We had a lot of, as you see, garbage, refuse, cellar dirt from construction, and we wanted to find a good place to put it. And this is the area we came up with, right there, which is kind of baffling to me that would be the spot we picked. But we did, and you can see some numbers there on the left. From 1914 to 1977, 200 million cubic yards were dumped. So you can see that little conversion on the bottom. We're talking about billions of gallons of material dumped in these regions. Billions of gallons right here in the New York Bight. And then in 1997, we decided that that was a bad idea. So we stopped doing that. We closed down that site due to some impacts on our local fisheries. Our lobster stocks were contaminated. Our dioxin, that's a industrial waste product found in worm tissue in the area. So because of that, we decided to remediate the area. And basically what we did was we capped it with clean sand. And that sort of does the trick. But here is a study showing lead concentrations, and this is from 1999. So many years later, we're seeing that lead, which shouldn't be in the water, is right where we dumped it. And then it's heading down the Hudson Shelf Valley towards the canyon, which is good because it confirms our theories on sediment transport in the area. We were right. The sediments are transported down the Hudson Shelf Valley, but it's bad because it's lead and it's entering new ecosystems and traveling from its original dumping site. So that is cause for concern. We decided to stop dumping in 97, but we decided to start dumping elsewhere. So we moved 106 miles out, right near the Hudson Canyon. And I have some pretty alarming stats on this in a second. Okay, so this began in 1986, and this dumping was mostly sludge, mostly wastewater from wastewater facilities, sewage, and we dumped a whole lot of it. So for 6 years only, we did it from 1986 to 1992. In 1992, we decided it was a bad idea. We stopped doing it. But the volume of sludge discharged at the site represents approximately 1/2 of the world's ocean sludge disposal volume in 1986. So 1/2 of all the sludge generated on the planet in that year was dumped here. We didn't just dump our sludge; we dumped other people's sludge here as well. It was the planet. 106 miles seemed like it was far enough out, and the thinking was that it would just be caught up in the currents and just kind of washed away and diluted. And in 1989, while we were still dumping, we were getting the technology to get down there into the canyon, and we saw that that was not the case. The sludge was depositing on the floor of the canyon and areas nearby, specifically this yellow area here. In 1992, we stopped doing it. We no longer dump, and no municipality in this region dumps in this area anymore, which is a great thing. Does anyone know what we do with our sludge now? Anyone familiar? So we don't dump it in the water. We ship it off to other states in the United States, and they deposit it on land in specified areas. Some of these areas, the sludge is used as fertilizer for crops that you and I might eat, which some studies have shown, yes, it is a very effective fertilizer and helps plants grow faster. Good, that's a good thing. Other studies show heavy metal concentrations are taken up by these plants and enter the human food chain, basically. So I wanted to bring this up because it is a success story in a way. We had a lot of people come together. Scientists brought their data, and policymakers decided we're done. We're done dumping in this area. It hasn't been effective. The claims that we made initially are not true. And so policymakers came up with a solution that protected this area. It also goes to show how there's never really a perfect solution to environmental issues. Specifically, what do we do with our waste? So we have to make tough decisions as we try to protect a lot of these areas. And this is a kind of an interesting story in the region. So just thought I'd talk a little bit about ocean dumping. I think I'm done talking about ocean dumping for now. Yeah, studies have shown that most of the Hudson Canyon has been unaffected by this practice. A lot of those heavy metals I showed in the previous slide are not present in high concentrations in the canyon, just in the Shelf Valley. And most of this site is slowly recovering over time. So over time, we will, as long as we don't continue to dump, have a system that is close to where it was when we started. Okay? All right. Questions. I'm going to open it up to questions now. Talked about a lot of different things, but does anyone have any questions? I have some questions I'd like to kind of discuss with the group, but does anyone have anything first? Yeah, Megan.
So you might just have to repeat questions for people who are watching at home.
Sure.
But
Do that.
my question is, why do you personally think that we know more about planets in our solar system than we do our own ocean?
Yeah, so the question is, why do we know more about planets in our solar system than we do about our local oceans? And I'm not sure if I have a great answer for that.
It's more of like a personal.
Yeah,
answer
I will say the technology to get down there has just started to come on, and we're just kind of at a point where we're very comfortable and we can get down to these great depths in the ocean. There's a lot of logistical issues getting down there and collecting data down there. But why hasn't that been a priority?
Because space, I mean, there's some logistical issues
Yeah,
in that.
you're right. Space is kind of tricky to get to as well. I will grant you that. Yeah, I don't know. But on the bright side, we seem to have a grasp of the technology that's necessary, and we seem to be turning a corner as far as being able to explore these areas. And I will say, this coral amendment, I'll go back to it. is a very proactive amendment. There isn't a lot of damage to these areas yet because fisheries don't have the technology to get down to these spots yet. So protecting these areas before we start trying to exploit them economically is something that is happening, and hopefully this amendment will be passed. Hopefully they have a good meeting tomorrow. And
do you think we need more deep sea movies to counteract like The Martian, which is like there's so many space movies out there, but I cannot name any deep sea. Deep sea.
The Abyss.
Yeah.
There's that James Cameron one about exploring the Mariana Trench.
The Abyss.
Yeah, that one.
So I don't think we can count on Hollywood here, unfortunately.
You tell the right story.
It's James Cameron.
But I think what we can count on is that video footage I showed in the beginning, 7 minutes of just the best of that exploration. I think that's awesome stuff, and I think it's also on the NRDC website. I think they're really trying to push that video to kind of justify this new amendment that's coming
Because I
up.
just think about our visitors too, how we get them engaged with our local wildlife when obviously there are obviously restrictions, to what we know. So it's hard to get people engaged when we already don't. We're just getting the science now for a lot of areas. So,
Right.
But because that's my educator cap on.
There was also a terrific NOAA episode this last week on the bioluminescence.
Yes, I saw that. Yeah.
That was really, really interesting.
Yes, so yeah, I also saw that. So they talked about really deep sea animals and all the different adaptations.
That kind of really draws some people in, but not everybody watches NOAA.
No, I caught that one. That was a good one.
You can see it on the web.
You can, yeah. So these two blue lines, there's one up here and this lower one's kind of blocked out. This just designates the mid-Atlantic. It separates the mid-Atlantic fishery from the region north. Maybe it's called the New England fisheries. So this is just the zone that this council has jurisdiction or whatever in. So it just kind of delineates the bounds of their. Yes, so this amendment here would directly affect fishers trawling in these areas. Those trawl nets have shown to be cause significant damage to coral communities. So they would be outlawed. You can't even have that type of gear on a boat if you're sailing through this area. That's what the amendment is proposing. You can have crab pots in that area, but if you're caught there, you would be breaking that proposed law. Okay. Any other questions out there?
If the Hudson Canyon is going to wind up in the Ocean Wonders exhibit, or have you seen anything, or some of it, or?
I'm not too sure, actually. I didn't check into that. All I did encounter was that whale acoustic study, and that's going to play a role in the new exhibits, I think, at the aquarium, as well as you're going to be able to access it online as well. So you'll be able to track whales at the aquarium, you'll be able to track whales at home.
There's so many more whale sightings right on the tip of Manhattan. I've been going out on the American Princess, and they're just full of a dolphin, project dolphins.
Yeah. There was just.
You can see the Empire State Building in the background.
Yeah, it's great. Yeah, there was just a report by WCS, and there's a really cool map just showing all the different sightings that have happened over the past few years. There's a ton of mammal activity in the Hudson Canyon region, And there's a lot of reasons why they like the area, and we're still trying to understand exactly. Yeah, okay. So yeah, they are definitely in our waters here. We're figuring out the Hudson River. It is a work in progress, yes.
And there's also OCEARCH, which is, I don't remember how to spell the acronym, but I'll figure it out. You can actually track in real time the sharks that are in the area as well. A lot of the sharks are tagged, and you can see like where they are. And it was really funny because there was a shark named Princess that was in our area recently. But I think it's OCEARCH. But it's really cool. And there's an app where you can actually plug in and see where the sharks are in the area too. So.
Kimberly?
Yes. The first slide you showed us showed how Blue York made that image of the different animals that are in the waters, and I know they're also supporting the ban on microbeads. Have microbeads made an impact at all, even if not in the Hudson Canyon or the Hudson Shelf?
So we had a question about microbeads, and I'll go back to the first slide. You can see that wonderful watercolor. Again. Yeah, so part of our Seascape, part of our Blue York program has been tackling the microbead issue. And I know Cheryl's been working on it. Cheryl's here in the room right now. I haven't been too up to date. I know Congress did pass some sort of legislation banning microbeads. So nationally, I believe that's the case. The research that I looked at didn't look at microbeads in particular, so I can't really comment on specifically the impact they've had on the system. But I do know it's part of what we're working on, and it's amazing actually how fast things have come together on that front. So yeah. Any other questions? Yeah. Microbeads. Yeah. So microbeads are these little plastic particles that are in a lot of our products, a lot of like soaps and shampoos. It's basically someone had the bright idea to just put garbage inside of soap and to help kind of like as an exfoliant. And we were finding these plastics all over the ocean. So Congress has taken steps to ban that kind of practice. Okay. Any other questions? So I have some questions for you guys. I know a lot of us here are educators that work with younger audiences, and we have camp coming up, summer camps coming up, and we're looking to plan curriculum. Based on just kind of the overview I've given today, does anyone have any thoughts on like takeaway messages from this, or talking points, or maybe even activities or games? How do we talk? I don't think you're going to do a PowerPoint presentation during camp. So what do you, are there any thoughts on how you translate this type of information for the audiences that we see in the summer and for the FAs out there, just in-park interactions? Is there anything that jumps out at you as being really a good talking point or useful information? Yeah, Christina.
The whale tracking, definitely when that's done, I think it'd be really cool if you say you can like do it on a cell phone, or you can even pull it up on like a computer to track, show here's a whale that's, right here in our midst. I think that'd be a really cool way to show that we're part of an ecosystem. New York isn't separate from the ecosystem. It's an ecosystem in and of itself.
Yeah, absolutely. So Christina was mentioning the whale tracking that's happening. Let me just keep flipping through here. Yeah, here's a whale. So the whale tracking does come close to home, and it's something that definitely kids can understand and appreciate. Any other ideas, thoughts? Yeah. Yeah, Kim?
I like the when you brought up the fact that we were dumping sludge, but then we had the bright idea to use it as fertilizer. And even though there are problems with that, I think that it's a good thing to mention to kids to show, like, hey, we had scientists, they came together, they collaborated to find a solution, and they're still having trouble. So I think it's just a nice way to demonstrate that for a lot of kids who might feel discouraged about saving the environment, that it is possible to collaborate with scientists and come up with new solutions and continue to come up with solutions.
Yeah, absolutely. So yeah, taking them through the process of developing policy and looking at all the different options out there. Yeah, one more thought. Go ahead.
I'm really big on like mystery detective things, and I think the whole aspect of like the deeps of the ocean being unexplored and like the scientists don't know what they're going to find down there. So like especially for little kids to get excited about it.
Yeah, so I actually really enjoyed reading these papers because I kind of felt like I was down there in the ocean on a submersible learning about these environments. Kids might not feel the same way about reading a scientific paper.
Well, yeah, you don't have to.
But yeah, there are ways to kind of simulate that for them, like games or activities, things like that. So yeah, absolutely. Yes.
There's an excellent website. You read the alert.org. You get every scientific journal, Nature, Astronomy.
Great. So it just kind of updates you on the latest discoveries, latest research.
All the publications, but if you backdoor go to the index, you don't get abstract.
Great. Okay, I think this is going to be our final thought here. Yes.
You could also, as the kids are cleaning off their lunch trays, ask them if they have any idea where all that garbage goes to, and maybe push recycling. Like I'm a real compulsive recycler, and everything gets separated. And for some people do arbitrarily just throw everything into one bin, and they just don't give any thought to it. It's like their brain stops it when they throw their face. So they can push the recycling, and hopefully that's being carried out by your local municipalities, but you have to do your part. And you instill that at an early age, it does stay with them. And we underestimate the younger kids because they just drink it all up.
Yep.
And they get to be the nags of their parents, recycle things and such.
Great. We're going to bring this session to a close. I want to thank everyone for coming today. You were a lovely audience, and thank you for everyone tuning in out there at home and in your offices. Thanks for coming. It's been a lot of fun, and we're going to shut things down right here. So thanks again.
Everybody, thanks for coming again, and I'll keep you posted on when the next one is. I actually forget when the next one is, but it's probably got a couple more weeks. So I'll email everybody again, but thank you, everybody.
The whale watch later time?
Yeah.
Yep. Yep, right here.
So, did you collect my email?